A composite shaft rod of 60 mm diameter surrounded by a closely fitting tube of brass. To stop. Find the outside diameter of the brass tube when a torque of 1 kilonewton meter is applied on the composite shaft and shared equally by the two materials. To stop. Take E for steel as 84 GPa and C for brass as 42 GPa. Full stop. Also determine the common angle of twist in length of 4 meter. Okay, so first of all, write down the given data for that. So diameter of steel it is given, that is 60 mm. 60 mm. So diameter surrounded closely fitting the tube brass. Then we need to calculate the internal diameter of brass. It is 60 mm. Okay. So external diameter of brass we need to calculate. External diameter of brass we need to calculate. Surrounded by fifth. Find the outside diameter of brass when torque it is. Total torque it will be given 1 kilonewton meter. 1 kilonewton meter. Okay. So applied on the composite shaft shared equally by the two materials. Means torque share by steel it will be equally means 0.5 kilonewton meter. 0.5 kilonewton meter shared by the steel, and torque shared by the brass it is also 0.5 kilonewton meter. Okay, so this data it is given here, applied on the composite share and shared equally by the two materials. So it is shared by the equally. That's why it will be TS is equal to 0.5 kilonewton meter and TB is equal to also 0.5 kilonewton meter. Okay, so next take C for steel, it is as 84 GPa. C for steel, modulus of rigidity for steel it is 84 GPa. Okay, so convert it is in Newton per mm square. That is 84 into 10 raised to the power 3 Newton per mm square. Newton per mm square. Okay, when GPa to Newton per mm square, it will multiply by 10 raised to 3. Okay, then modulus of rigidity for brass it is equal to, it is 42 GPa. 42 GPa. Okay, so 42 into 10 raised to the power 3 Newton per mm square. 10 raised to the power 3 Newton per mm square. Newton per mm square. Okay, so this one it is modulus of rigidity for brass. Okay, then total length it will be given, L is equal to 4 meter. L is equal to 4 meter. So this data it is given. Okay, so first of all we need to calculate the diameter of brass. Okay, so torsion equation, polar moment of inertia. First of all, calculate polar moment of inertia for steel. That is solid rod. Okay, solid steel rod. So IP is equal to, write down IP is equal to, for that pi into so diameter of steel it is ds, we are noted it is ds raised to 4 divided by 32. Okay, so IP it is Ixx plus Iyy, so it will be directly, it will be at pi d raised to 4 divided by 32. Okay, polar moment is equal to, so pi into so diameter of steel it is 60 raised to 4 divided by 32. Okay, divided by 32. So it will get polar moment of inertia for steel, pi into 60 raised to 4 divided by 32. It will get 1.27 into 10 raised to the power 6. 10 raised to the power 6 mm raised to 4. Okay, so I will note down this value. It is also, so IP is equal to 1.2723 into 10 raised to the power 6. This one it is for steel. Okay, for steel. Okay. So now calculate polar moment of inertia for brass. So next, polar moment of inertia for brass. Polar moment of inertia for brass. Okay. Calculate polar moment of inertia for brass. So it is hollow tube is equal to pi into dB raised to 4 pi into external diameter dB raised to 4. The diameter of brass, dB it is the diameter of brass, minus small dB raised to 4 minus small dB raised to 4 divided by 32 divided by 32 okay, is equal to pi. External diameter of brass we need to calculate. This one. It is dB, it is unknown. dB raised to 4 minus small dB raised to 4, it is 60 raised to 4 divided by 32 okay, divided by 32 okay. We can write down this one in terms of dB raised to 4. 5 by 32, it will be 0.0. Leave this one. Okay, here. So now next, angle of twist, torsion equation in terms of angle of twist, in bracket we can say it will be theta b. Okay, so theta, it is denoted by theta. Okay, so in terms of torsion equation, T divided by ip is equal to c theta divided by is equal to c into theta divided by L. So this one it is torsion equation in terms of modulus of rigidity and angle of twist. Okay, so theta is equal to, we need to theta is equal to T into L divided by 2 into L divided by IP into C. Okay, so first of all, theta for theta S, angle of twist for steel, it is T into, so you can say it is TS into LS divided by IP into CS. Okay, CS. So I will note down polar moment of inertia for brass. It is, so this equation it is pi dB raised to 4 minus 60 raised to 4 divided by 32. Okay, so this one it is for brass. Okay, so now we will erase this part. Okay, now theta S is equal to, put all this value, TS into LS divided by polar moment of inertia for steel. It is, we are calculated this value, it is 1 point something, 1.2723 1.2723 into 10 raised to the power 6 into so CS it is for steel it is 84 into 10 raised to the power 3 84 into 10 raised to the power 3 okay. 4 into 10 raised to the power 3. So theta s is equal to, write down final equation, theta s is equal to TS into LS divided by so 1.2723 into 10 raised to the power 6 into 84 into 10 raised to the power 3. So it will be 1.0687 into 10 raised to the power 11. 10 raised to the power 11. So this one it is theta is equation. Now theta C, similarly calculate theta B, sorry, angle of twist for brass. So it will be TB into LB, TB into LB, torsion shear by brass, that is TB. IPT is, we can write down IPT is pi by 32. Okay, pi by 32 it is 0.0, IPT is 0.09817 into, in bracket, TB raised to 4, TB raised to 4 minus small TB raised to 4, that is small TB raised to 4, it is 64 raised to 4, 60 raised to 4, 60 raised to 4 divided by, first of all, sorry, write down the equation for that. TB LB divided by IP into CB. Okay, modulus of rigidity of brass. So put all these value here. TB into LB, TB into LB divided by polar moment of inertia, it is pi by 32 capital dB raised to 4 minus small dB raised to 4. So pi by 34 it will be 0.09817 into capital dB raised to 4, capital dB raised to 4, then small dB raised to 4 it is 60 raised to 4, 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 then now remaining it is CB, it is 42 into 10 raised to power 3. Okay, so write down, simplify this, theta B is equal to TB into LB, TB into LB divided by TB into LB divided by 0.09817 into 42 into 10 raised to power 3. It will be at 4.1233 into 10 raised to the power 3 into, in bracket dB raised to 4, in bracket dB raised to 4 minus small dB raised to 4, that is small dB raised to 4, it is, we have put this value 60 raised to 4, 60 raised to 4, 60 raised to 4. Okay, so this one it is theta B. Okay, Therefore, theta S is equal to theta B. So equate these two equations. So equate these two equations. Equate these two equations. Because of composites, so angle of twist will be equal. Okay. Because of composite. So theta S is equal to theta B. Write down here. Theta S is equal to theta B. Okay. Theta S is Ts into Ls divided by 1.0687 into 10 raised to the power 11 is equal to, now theta B, it is Tb into Lb divided by 4.1233 into 10 raised to the power 3 into write down here this one into in bracket Tb raised to 4 then minus small tb raised to 4 minus small tb raised to 4, that is 60 raised to 4 bracket close. So here only unknown it is tb raised to 4. Okay, tb raised to 4. Okay. So here tb is equal to, here ts is equal to tb is equal to, it is 0.5 kilonewton meter, 0.5 kilonewton meter, that is 10 raised to 6 Newton mm, that is 0.5 into 10 raised to the power 6 Newton mm. Okay, and L is equal to LB. So this it will be get cancelled. LS is equal to LB. The length it is same because of composites. Okay, so that's why this it will be get cancelled. So now, so this it will be take this side. So in bracket TB raised to 4 minus 60 raised to 4 minus 60 raised to 4 minus 60 raised to 4 is equal to 1.0687 into 10 raised to the power 11, 10 raised to the power 11 divided by 4.1233 into 10 raised to the power 3, 10 raised to the power 3. Okay, it will be get so db raised to 4 minus 60 raised to 4 minus 60 raised to 4 is equal to, so 1.0687 into 10 raised to the power 11 divided by 4.1233 into 10 raised to the power 3. It will be 25.918 into 10 to the power 6, 10 to the power 6. So dB raised to 4, add dB raised to 4 is equal to dB raised to 4 is equal to 25.918 into 10 to the power 6 plus 60 raised to 4. 60 raised to 4. So dB raised to 4 is equal to 38.878 8785 into 10 to the power 6, 10 to the power 6. So dB diameter of brass is equal to, now diameter of brass is equal to raised to 1 by 4, raised to 1 by 4. 38.8785 into 10 to the power 6 raised to 1 by 4. It will be get diameter of 78.96, 78.96 mm. So diameter of brass it is 78.96 mm. So next, also determine the common angle of twist. Okay, so angle of twist it will be same. So equate, take any one equation from this. Okay, that is, we will take theta s is equal to here ts into ls divided by ts into ls divided by, so ip it will be 1.0687 into 10 to the power 11, 10 to the power 11. So put all this value here. So ts it is 0.5. We'll write down here this side. So theta s is equal to ts is equal to ts it is 0.5 into 10 to the power 6 into ls it is 4 meter, it is 4000 mm, converted in meter to mm, divided by so it is ip into cs, this value we are calculating 1.0687 into 10 to the power 11, 10 to the power 11. So this value it will be get in radians. Okay. So theta s is equal to it will be get in radians. 0.5 into 10 to the power 6 into 4000 divided by 1.0687 into 10 to the power 11. So it will be 0.01871 in radians. Convert it is in degree, multiply by this value 0.0187 into 5 by 180 by 5, 180 by 5. Okay, 180 divided by 5 to be get in degree. Theta is equal to it will be 1.07, 1.072 in degree. It will be get in degree. Okay, so this theta it will be 1.72 degree. Okay, so this one it is the angle of twist and external diameter of brass it is 78.96 and angle of twist it will be 1.072 degree. It will be same for both, for brass as well as for steel.